number of turns of the armature, then it will be N S into B cos theta. We can change this theta, angular speed is equal to theta by t, and from there theta can be eliminated with the help of omega t. So omega is the angular speed and t is the time, instantaneous time. Sidewise it is shown. And also E is equal to minus d phi by dt. So after differentiating the above equation, we will get nsb omega sine omega t. That is E is equal to E naught sine omega t, where E naught is the maximum EMF induced, and that will be when sine theta will be 1, then EMF induced EMF will be maximum, and that maximum is taken as E naught, peak value of the EMF. So E is equal to E naught sine omega t, where E naught is equal to NSB omega. Here it is worthy to note that in a generator, the induced EMF lags with flux by phi by 2. Flux and induced EMF both have, you can see, one has cos omega t, other has sine omega t. If you convert sine omega t in cos omega t, then you will get the phase change by pi by 2. So EMF lags, EMF will be behind it. Here it is negative sign, so it will be lag by pi by 2 in the phase. That is when the flux, the maximum, when the flux is the maximum, the coil is, that means the coil is vertical, the EMF is 0. When the coil is vertical, means angle between magnetic field and flux, it is 90 degree, then sine 90 degree will be 0, sine 90 degree will be 0, and therefore when the flux is 0, means that the coil is horizontal, parallel to the magnetic field. At that time, the EMF is maximum. So this is all about the electric generator or dynamo. Now come to another topic where induction, self-induction or mutual induction is used, that is transformer. As we have teaching in the standard 10 also, in 12 also, and in principle we used to say that in one word, the principle is mutual induction. So this is the transformer is the circuit in which mutual inductance is taking place. So let us, transformer is a device which raises or lowers the voltage in AC circuit through method of induction and consist of two coils wound on the same core. Method of induction, mutual induction. So sometimes we need to increase voltage. Voltage means potential difference. When we are increasing the voltage, current will be lowered, and when the decreasing voltage, the current will be higher, as the power remains constant. The coil connected to the source is called primary, while the other which to connect to the load, which is connected to the load, is called secondary. Load, first the coil connected to the source where input is given, input current and voltage is given, that will be the primary coil, and the secondary coil where the EMF is induced, that will be the secondary coil, or you can say load is connected to the secondary coil. The alternating current passing through the primary creates a continuously changing magnetic flux through the core. If we are connecting the alternating current in the primary, alternating current is a variable current. So if it is connected in the primary, then it creates continuous changing flux through the core. This changing magnetic flux induces an alternating EMF in the secondary coil. As the magnetic lines of the cores are closed curve, the flux per turn of the primary be equal to the flux per turn of the secondary. That is, you can see this is the figure of the transformer. Laminated cores or core materials are used. Primary, in the primary there is a AC source, symbol of AC source. In the secondary, output load is given, and according to this, secondary flux, magnetic flux in the secondary divided by number of turns in the secondary is equal to magnetic flux in the primary divided by number of turns in the primary. And as the number of turns in each coil is constant, and therefore after differentiating we get 1 by ns d phi s by dt and 1 by np d phi by dt. So d phi by rate of change of flux is equal to induced EMF. So it is secondary, so ES, and d phi p by dt, it is in the primary, so it will be taken as EP. So ES by EP, if we calculate ES by EP, we will get NS by NP. So there is a relation between E and primary EMF and secondary EMF with the number of turns in the coil in the transformer. As in an ideal transformer, there is no loss of the power. If the transformer is ideal, so there will be no loss in the power. Power losses will be zero. So input power is equal to output power. Input is equal to output. So EMF induced is equal to voltage, and P power is equal to VI. That will be constant. From there we can calculate relationship between EMF, current, and number of turns, which is shown in the equation number 3. You can see it in the PowerPoint presentation. Now there are two possibilities in the transformer. Number A, number of turns in the secondary is larger than number of turns in the primary. The transformer is said to be step up, means it will increase the voltage, output voltage, with respect to the input voltage, and it increases voltage and reduces current because power remains constant. VI is equal to constant. Second point is, if the number of turns in the secondary is less than the primary, the transformer is said to be a step down, and it reduces voltage and increases the current. And we have to summarize main points here regarding transformer. It is worth noting that number one, it works on AC only and never on DC, because DC is constant, and when constant current is given to the transformer, input of the transformer, no magnetic flux will change, no field lines will change, so there will be no induced EMF in the secondary. So it will not work in the DC, it works only in AC. It can increase or decrease either voltage or current, but not both simultaneously, because power remains constant. Either voltage is increased or current is increased. Both are not increased simultaneously. Next point, some power is always lost due to the flux in the transformer. It is not ideal. Ideal. Yes, sir. Yes, sir. Okay, sir. This slide I have told, I have discussed this slide. You can see, sir. May I change this? I'm kissing, sir. Now, the next third point, some power is always lost as a transformer is not ideal. Any man-made devices are not 100% ideal. So there are some losses, and that losses is due to flux leakage, magnetic flux produced in the primary. All the flux may not linked with the secondary. So some magnetic flux will leak out, and due to which there is a loss in the efficiency of the transformer. So this is called as flux leakage loss. And hysteresis losses. Hysteresis is the lagging of magnetic induction with the magnetizing field. If you apply the magnetizing field on any magnetic material, as the transformer has core material like soft iron, so iron is a magnetic material. When AC current is given, a coil is wrapped on this core, iron core. So electric current AC is applied. As we know, amplitude of AC continuously changes, direction also changes. So frequently, this core material getting magnetized, demagnetized, continuously it is going on. So if we draw the curve showing magnetizing field and induced magnetic induction, and we get a loop, and that loop is known as hysteresis loop, and at that time we will the area of the loop gives the losses of energy. That is calculation of the hysteresis losses. Similarly, ED current I have explained because alternating current is applied on the core material, and so varying magnetic field is applied, and due to which circulating current is induced in the core material. To minimize this, we are using a laminated core in the transformer. That is why we are always telling that core material should be well insulated and laminated. If you passing through the way and you are looking over the transformer, humming sound is coming out. So sound is produced on the cost of the energy, electrical energy, alternating current applied to the transformer, input of the transformer. And humming current is due to the looseness of the binding of the coil on the core material. Copper, well insulated copper wire is wrapped over the core material, and due to the long time and heating effect, elongation is there. So there may be looseness of the coil, and due to looseness of the coil, there is a vibration in the coil, and that produces humming sound. So some parts of the input energy get lost in terms of producing humming sound, and we all have seen that there is a heating effect of the coil, and nothing is purely inductive or purely resistive और प्योरली कैपेसिटिव अल्टरनेटिंग करंट में हम लोग पढ़ाते हैं कि ना तो कोई प्योरली रेजिस्टिव है, ना तो इंडक्टिव है, ना तो और भी है. तो यहाँ पे जो है ड्यू टू सम coil is there, means it is inductor, but it has some resistance, due to some resistance, there is heat produced from the formula. I have discussed it previously that I square R is the formula to produce heat in the electrical circuit. So R is there, resistance is there. In spite of we are using coil, there is resistance. So due to that resistance, heat is produced in the coil. So in the transformer, there is a loss, heating loss, and this it is due to copper wire. So it is also known as copper loss. And hysteresis or ED current losses together, it is also known as iron loss, because it is due to the iron part of the transformer. So now some electrical circuit in which mutual induction of the is taking place. In next slide, mutual inductance or induction in some electrical circuits. And here I have considered the two long solenoid, which is in the syllabus of the +2, and EM electromagnetic in the chapter of electromagnetic induction. So coil is here, two long solenoids of the same length and same area, having different number of turns, is shown in the figure. Okay, primary and secondary, in which we will put the current, that will be primary, and from where we can take the output, that will be that secondary. Okay, so this is the secondary and primary coaxially. Next, here is the
मैडम के सामने सबसे आगे
shown here. Sound is coming, Vikas Chaudhary sir. Unmute कर लीजिए, please unmute yourself sir. चौधरी सर.
Yes, sir.
हाँ, बात करेंगे तो अनम्यूट कर लीजिएगा थोड़ा सा, है ना. तो we have this, in this figure, S1 and S2 are the two coaxial long solenoid of length L, and everything is given in this slide. Okay, so flux phi 21, flux in the secondary coil due to the primary is directly proportional to the current flowing through the primary coil. That is why I21 is directly proportional to I1. Primary में जितना current जाएगा, whatever the current is passing through or changing through the primary, flux produced in the secondary is due to that. So flux 21 is directly proportional to this I1, and then this phi 21 is equal to M21 into I1. This is equation number 1. M21 is the coefficient of mutual inductance of the two solenoid when current is passed through solenoid S1 and induced EMF is produced in the second S2 solenoid. Now magnetic field produced inside the solenoid S1. What is the magnetic field? What is the theme behind it? We have to calculate the total flux produced in the primary, and we will consider that all the flux produced in the primary will link up with the secondary, because both are coaxial and wound over each other. So to calculate the flux, we have to calculate first magnetic field intensity, magnetic induction, magnetic field intensity produced in the primary due to the current changing I1 in the primary. So that will be given by, in the solenoid B is equal to mu naught Ni. So B1 is equal to mu naught N1 into I1. Here it is B1 N1 I1, where B1 is the magnetic flux produced in the primary, N1 is the number of turns of the first solenoid, I1 is the current passing through that. So magnetic flux linked with each turn of the secondary. Whatever magnetic field is produced, from there we have to calculate magnetic flux, and that will be B into A. So B1 here in the above equation, B1 is there, you can see in the slide, and if it is multiplied by area of the solenoid, as we have considered, area of both the solenoid are same, length are same. So A is the area. So magnetic flux linked with each turn is B into A. That is B1 into A. So the last, it is given B1 into A. And substituting the value, okay, the total, what will be the total flux linked with the secondary, second solenoid or secondary solenoid. So flux associated with each turn multiplied by total number of turns of the secondary coil. So B1 into A multiplied by number of turns of the secondary coil into current, into length of the second. So length and area both are same. We have taken here same of the both the solenoid. So N2 into L is multiplied here. N2